All right, when factoring second degree trinomials, there's a certain type called a difference of squares. So difference is subtraction. That's your first hint that it could be difference of squares. The other hint is that they are perfect squares. So what are perfect squares? Well, the square root of 9 equals 3. The square root of 4 equals 2. The square root of 1 equals 1. The square root of 25 equals 5. These are all perfect squares, okay? All of these numbers underneath the radical, you can take the square root of. So they're perfect squares. Again, square root of 36 is 6. Perfect squares. Whereas something such as the square root of 48, that's not a perfect square because that's actually 4 root 3. Comes out weird when you get your answer. You don't need to know this last one right now. Okay, don't even worry about it. I'm just showing you what a non-perfect square looks like. It still has a radical when you simplify it. So let's first multiply. Let's do FOIL. So x times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is minus 9. When you simplify it, what do you get? You get x squared minus 9. Notice that in the difference of squares, your middle term, your x term, cancels itself out. Did you know that you can rewrite x squared minus 9 as x squared minus 3 squared? This is another big hint for you that this is a difference of squares. Okay? So let's utilize this. The difference of squares states that a squared minus b squared is equal to a minus b times a plus b. Well, we can rewrite this as x squared minus 5 squared. So if we follow that pattern, we will get x take away 5 times x plus 5 as our factored form. Now, let's say we don't like a difference of squares. Let's say that this is a method we just don't like. So let's relook at x squared minus 25. Note another thing you can ask yourself that's easy. What multiplies to negative 25 but adds to 0? Well, in order to add a 0, it has to be opposites of each other. So the only way we could do that is if we had 5 and negative 5. So we'd still get our x minus 5 times our x plus 5. It's just another way that I've learned over the years to explain it to people. If I say difference of squares, they look at me weird. But if I say what multiplies a negative 25 but still adds a 0, usually it pops in their head a little bit better.